In this video, I will demonstrate how to compute a confidence interval using t-values. Let's read the problem. It states the following. Assume that the entire population of employees at Atlas Realty in Northridge, California is 50 employees. Use the t-distribution to estimate the average age of all employees with a 95% confidence level. A sample of 9 ages, so we're selecting 9 random ages from the 50 employees, have been randomly collected and they're displayed here. Compare your values for the confidence interval to the actual mean, which is 44 years old. So we will compute the limits using the sample data, and then we will compare the limits of the confidence interval to the actual mean. Now, when data is presented or listed in this manner, it is called raw data. So we do not have summarized data. Summarized data is like what I have listed below, where it tells us directly what the mean is and the standard deviation is. What we need to do is we have to compute the sample mean and the sample standard deviation. We can do this using either Microsoft Excel. I have videos on how to perform those computations, or we can use a scientific calculator. Let's do that in this case. So I'm using a standard TI calculator. Every calculator has a different process for finding those values we discussed. Step 1, we have to enter the data into the calculator. To do this, I click on the data button and then I type in each data value. 44, 42, 43, 31, 48, 59, 26, 61, 35. Once all the data values have been typed in, I need to access the stat button. So I have to use the second button, click on data, and then I want to select the one variable stats. L1 is the name of the column where I typed in the data values, so we'll leave that highlighted. Also, we leave the frequency highlighted. Use the down arrow to select calculate, hit the enter button, and we have our key values. N is 9, X bar is 43, we'll round to 1 decimal place, so 43.2. The standard deviation S, it's a sample standard deviation, is 11, we'll round the 2 decimal places, 0.74. So that's how I was able to derive this information. Keep in mind that mu, the population mean, is unknown. We're estimating that value. We're making that assumption. It's actually 44. We'll come back to compare the 44 with our actual limits that we compute. X bar is 43.2, N is 9, S is 11.74. Now we have to find the t-value. To find the t-value, we need to compute degrees of freedom. So degrees of freedom is n minus 1. So it's 9 minus 1, which is 8. We can use degrees of freedom along with the confidence level to find the t-value. We will use table F to look up the t-value. That's where all the t-values are located. So in table F, the confidence level was 95%. Degrees of freedom is 8. So we can locate the t-value. It is 2.306. So that's why I have that listed there. Now the formula to compute the confidence interval with a t-value is on the left. For the left endpoint, it's x bar minus the t-value times the sample standard deviation s over radical n. On the right side, it's the same formula but with the plus. Our next step is we insert all the values into their proper locations. So x bar is 43.2. The t-value is 2.306. S 11.74, and then we divide by radical 9. I want to show you how to key in these values into a standard calculator. So let me clear all the old data and let's go ahead and do this. So we have 43.2 minus 2. Let me just make sure I have the correct t-value, 306 times 11.74 divided by, we have to use the square root, so second square root of 9. Select enter, and we have our first limit. It's 34 point, if we round it, 18. So 34.18. To compute the right endpoint, we do the following. You could retype all the values into the calculator, or we can use the arrow to highlight the equation we typed in, select enter, and then we can edit the formula and just change the minus sign to a plus sign. And this will give us the right endpoint. 52, we can round it to 2 decimal places. So we have a confidence level that's estimating the mean ages of employees at this place of business. It's the ranges from 34.18 to 52.22. It so happens in this example we have the actual mean age. It's 44, and 44 is right between these two limits. Thus, the confidence interval we computed actually captures the true mean. Thanks for watching this video.